We are starting with exercise 8I. Okay. Question number 1. X is equal to Ct, y is equal to C upon T. Okay. Now see over here, C is a constant because A, B, C, K, they are generally constants in mathematics or in calculus. Okay. So C, if C is a constant, what is T? T is the variable over here. Okay. Now in this case, X and Y, they are functions of T. So T becomes the parameter. Okay. In all the other problems, Y is a function of X, but then here, Y is a function of T and X is also a function of T primarily. Okay, so T is a parameter, so this becomes parametric equations. They're asking you dy by dx. Now, y is not directly a function of x. Y is not a function of x. Then also they are asking you to derivate y with respect to x. So in this type of cases, we have to consider the parameter. Okay, so dy by dx is equal to dy by dt upon dx by dt. Okay, because x and y both are functions of t. So d by dt of c by t upon d by dt of ct. C being a constant will go outside. So C d by dt of 1 by t, C d by dt of t. C will get cancelled. So this is minus 1 by t square, which is the numerator, divided by d by dt of t, which is 1. So the answer is minus 1 by t square. Okay. Question number 2. X is equal to 1 upon 1 minus t square. Y is equal to 1 upon 1 plus t square. Y is equal to 1 plus t square. X and y, they are functions of t. T becomes the parameter. The main variable is t over here. Okay. Dy by dx, they are asking y is not a function of x, but then y and x both are individually functions of t. So dy by dt upon dx by dt. Let this be equation number 1. Y is equal to 1 upon 1 minus t square. Whenever the terms are big and complicated, don't do everything at once like the previous problem. Okay, so d by dt of y, d by dt of 1 minus 1 upon 1 minus t square. Okay, sorry, y is equal to 1 plus t square. So dy dt of 1 plus t square. So dy by dt is equal to 2t. No chain rule because we are differentiating with respect to t. So t is t over here and t square t is t. So this is dy by dt. Now x is equal to 1 upon 1 minus t square. Dy dt of x is equal to dy dt of 1 upon 1 minus t square. Dx by dt. Compare this with 1 upon t formula. The derivative of 1 upon t will be minus 1 upon t square. So if you're comparing with 1 upon t, who is t over here? T is 1 minus t square. So differentiation of 1 minus t square. Okay, so that is equal to minus 1 by t square into minus 2t minus minus cancel dt gone. So this is 1 by t. So this is dx by dt. Now what you have to do, you have to put the value of dy by dt and dx by dt in equation number 1 and further simplify. That I leave it up to you. Question number 3. X is equal to a 1 plus t square 1 minus t square. A is a constant obviously. B 2t upon 1 plus t square. Okay. So dy by dx is equal to dy by dt upon dx by dt because a is a constant, t is a parameter. So we start with this. When you differentiate this with respect to t, okay, b goes outside and here you do u upon v rule. When you differentiate this x term with respect to t, a goes outside and here for this bracket do u upon v rule. Okay. And once you get the answers, you can put back in equation number 1. Okay. Question number 4. X is equal to a theta plus sine theta. Y is equal to a1 minus cos theta. Okay. So dy by dx is equal to a and b are constants. So theta becomes the parameter. Dy by d theta upon dx by d theta. Okay. Because x is down, na, so dx by theta is the next term. Y is up. So dy by theta is the first term. So dy by d theta. differentiate this with respect to theta. So a is a, 1 is 0. Okay, minus sign remains as it is, and cos theta is sine theta. No chain rule because we're differentiating with respect to theta. Okay, and theta in cos theta is theta only. Okay, and here it's a outside. Derivative of theta with respect to theta is 1. dy d theta of theta is 1, and dy d theta of sine theta is cos theta. Okay, so a gone. This is your final answer. No need to simplify this further. The textbook people have done that. Not a requirement. Question number 5. So x is equal to b sine square theta. Trigonometric function with a power goes outside. Okay, y is equal to a cos square theta. So this is equal to a cos theta the whole square, right? So dy by dx, dy by d theta, dx by d theta. Okay, derivative of this, a goes outside the derivative, x raised to n, 2 into cos theta raised to 2 minus 1 into dy d theta of cos theta. Now this time chain rule will come because you are comparing this with x raised to n formula, that is theta raised to n. Okay, so theta becomes cos theta. B 2 sin theta, 2 minus 1 d by d theta of sin theta. Okay, 2 will get cancelled. You can simplify this further. Okay, you can also solve dy by d theta separately, dx by d theta separately, and solve. Right? Question number 7. X is equal to a cos t plus t sin t. Y is equal to a sin t minus t cos t. Dy by dx is equal to dy by dt upon dx by dt, because t is the parameter over here. Okay, equation number 1. So y is equal to a sin t minus t cos t. So d by dt of y, differentiating with respect to t. Sin t becomes cos t, and this is u into v rule. So I'll just put a bracket over here. V derivative of t with respect to t is 1, plus t into derivative of cos t is sin t. So dy by dt is equal to a cos t, okay, minus cos t. Now this plus into minus is minus, and that minus into this minus is plus. So plus t sin t when you open the bracket. So this is gone. So we are left with only t sin t, right? Now x term, x is this, okay? So similarly you have to derive, that's it. Dx by dt you calculate, cos t will become minus sin t, and this uv rule over here within the brackets. Okay, so that's how you'll get dy by dx by dt. And once you get dy by dt, which we have got over here, and dx by dt, which you should calculate on your own. Okay, what we'll do, we are going to put in equation number 1. Let's go to exercise 8J. Okay, now understand the format of this problem. Okay, first problem, or rather I'll take a difficult one, that is question number 4. Okay, so if I cover up 4, question number 1, 2, and 3 are also covered up. So I'll just write the statement as it is in this kind of problems. Okay, differentiate sine x cube with respect to sec square x square. So let this be u and let this be v. So this format you remember. Now read this way. So this is differentiate u, that is du upon differentiation of v with respect to differentiation of v. So this is u, right? This is v. So differentiating u with respect to v, that is du by dv. Now u is a function of x, v is also function of x. Okay, equation number one. Okay, u is equal to sin x cube du by dx. Sin x cube is cos x cube into d by dx of x cube. Chain rule will come. Okay, so cos x cube into 3x square. So 3x square into cos x cube. V sec square x square. So V is equal to sec x square the whole square. Okay, trigonometric function with a power, power goes outside. Now this is first x raised to n. So 2 into sec square x raised to 2 minus 1. Okay, so if I compare this with x raised to n, who is x? X is sec x square. So d by dx of sec x square. Okay, this will be 2 sec square x sec x square. Differentiation of sec x is sec x tan x. So sec x into tan x, but then square will come. Okay, because it is sec x square into d by dx of x square. So one more time derivative of x square. So this is going to be 4x. One second, I just have to write x square over here. Okay, sorry, x raised to n, 2 into x raised to 2 minus 1. Okay, this is the right format. Sorry, and x is sec x square. So this will be sec x square. Now sec x square into sec x square is sec square x square. So this will be 4x sec square x square into tan x square. Okay, so this is dv by dx. So final answer from 1 du by dv is equal to u by dx upon dv by dx. Okay, so du by dx is what? This. Dv by dx is what? This. So du by dx upon dv by dx. If any term is getting cancelled, only this term will get cancelled. X square upon x will be x. That's it. Otherwise, the rest of the terms will remain the same. Okay. Question number 5. So question 1. Differentiate tan inverse 2x with respect to tan inverse 2x upon 1 minus x cube with respect to tan inverse x. So this is u and this is v. Now read this way. So du by dv they are asking. Differentiating u with respect to v, which is equal to du by dx upon dv by dx. Equation number 1. Now u is equal to tan inverse of 2x upon 1 minus x square. Now this is ITF. This is 2 tan inverse x. Okay. So du by dx will be 2 into 1 upon 1 plus x square. This is du by dx. Okay. V is equal to tan inverse x. So dv by dx is equal to 1 upon 1 plus x square. So both we have got du by dx and dv by dx. Those values will substitute in equation number 1. 1 upon 1 plus x square will get cancelled up and down, and then we are left with only 2. Okay. Next problem. So question 2. Differentiate tan inverse of x upon root 1 minus x square with respect to 1 upon 2x square minus 1. Second inverse of 1 upon 2x square minus 1. Okay. So this is u and this is v. U is equal to tan inverse of x upon root 1 minus x square. Now see, this we have done in ITF also, ITF exercise of differentiation also. So let x is equal to sine theta because it is 1 minus, so sine theta. Okay. So this will give me what theta is equal to sine inverse x towards the end. So u is equal to tan inverse of sine theta upon, if x is sine theta over here, 1 minus sine square is cos square root is cos. So tan inverse of tan theta, which is theta. So u is equal to theta. So u is equal to sine inverse x. Okay. So du by dx, derivative of this, 1 upon root 1 minus x square. Okay. Now v is equal to sec inverse of 1 upon 2x square minus 1, which is equal to cos inverse of 2x square minus 1. Okay. Now this is the direct formula also, but then here you can put x as cos alpha. Okay. So alpha will be cos inverse x. So v is equal to cos inverse of 2 cos square alpha minus 1. Now 2 cos square alpha minus 1 is cos 2 alpha. So this is equal to 2 alpha. V is equal to 2 alpha. So put the value of alpha. Alpha is equal to cos inverse of x. V is equal to 2 into cos inverse of x. So dv by dx is equal to 2 minus 1 upon root of 1 minus x square. Now once you have got du by dx, okay, and once you have got dv by dx, okay, put this in equation number 1. So du by dv is equal to du by dx. Du by dx is 1 upon root 1 minus x square, and this is 2 into minus 1 upon root 1 minus x square, right? So this and this is gone. So this is minus half. Okay. Now third problem, I'll just give you a hint. Tan inverse of 2x upon 1 minus x square is 2 tan inverse of x. And sine inverse of 2x upon 1 minus x square, it should be 1 plus x square. Okay. Sine inverse of 2x upon 1 plus x square. That's minus in the textbook, but then it is 1 plus x square. And that is also 2 tan inverse x. Okay. So both are tan inverse x. So follow the same procedure. Du by dx will be derivative of 2 tan inverse of x, which is 2 into 1 upon 1 plus x square. And the second term is also same. V is also same. Derivative of 2 tan inverse of x. Okay. So there you can put dv by dx will be 2 into 1 upon 1 plus x square. So you put that in equation number 1. All the terms will get cancelled. Answer is 1. Now in the fourth sub question, differentiate u with respect to v. So the first one is u. U is equal to tan inverse of root 1 plus x square minus 1 upon x. You can put x as sec theta over here. Sorry, tan theta over here because it is 1 plus x square. And this we have done in ITF exercise of differentiation. So you can solve and you can get du by dx. Now dv by dx, v is straightforward. V is equal to tan inverse x. So dv by dx is equal to 1 upon 1 plus x square. So once you get du by dx, dv by dx, put in equation number 1 and finish it off. That's it.